Okay, we have reached solving equations with radicals. So the big key to solving equations with radicals is to make sure that you isolate the radical. That means that you get the radical by itself, on one side, completely by itself. This one already has the radical on one side, completely by itself. So we're okay to go ahead and square both sides. So that means over here, I get to square this side, and over here, I get to square that side. When I square this side, this square root will end up canceling out with that square, and I'm left with a. Over here, 9 squared is 81. Now, it would be great for me to say that's all you need to do and we're done. But you'll always need to take your answer and plug it back in. You always check whenever there's a radical or whenever you're solving equations with denominators. So you need to always check to make sure that it works. So if I take 81 and put it in place of my a, the square root of 81 really is 9, and so we're good. Down here, the radical's already by itself, so I square that side and I square this side. When I square this side, the square root cancels out with a 2, leaving me with 4x. When I square this side, I get 64. Divide both sides by 4. X is equal to 16. You can't just say that's the answer. Once again, you got to plug it back in and make sure when you plug it in, you plug it into the original. 4 times 16 is 64, and the square root of 64 is 8. So that's good. For number 3, radical's already by itself. So I can go ahead and square this side, and I can square that side. So when I square this side, the radical cancels out with that 2, leaving me with a plus 4. When I square this side, I get 36. Now in order to get the a by itself, I subtract 4 from both sides. And you get a is equal to 32. Don't just assume that it's correct. Plug it back in. So 32 plus 4 is 36. The square root of 36 really is 6. So this is good. Number 4 isn't isolated yet. In other words, we're going to have to work to get this square root by itself. So the first thing I'm going to do is move my 10 to the other side. That leaves me with 2 square roots of b equal to negative 10. Now I've got to move the 2. Right now the 2 is multiplied by the square root of b, so I'm going to divide by 2. And get that the square root of b is equal to negative 5. Then I have to square both sides. Now that I got the radical by itself, I can square both sides. That cancels that out, and I'm left with b equals negative 5 squared is a positive 25. But we have to check it. So back into the black. Square root of 25 is 5. Times 2 is 10. And 10 plus 10 is not 0. Let me write it out and make sure I'm right. So 10 plus 2 square roots of 25 is supposed to equal 0. 10 plus square root of 25 is really 5. 10 plus 10 is equal to 0. 10 plus 10 is 20, and 20 does not equal 0. Since it doesn't work, that means that cannot be your answer. Which means your answer must be no solution. Once again, you need to make sure you check every single answer into the original problem to make sure it comes out correct. Up here, we don't have the radical by itself yet either. So I need to add 2 to both sides. That gives me the square root of 2x minus 3 is equal to 6. Now that my radical is by itself, now I can square both sides to get rid of that radical. Which leaves me with 2x minus 3. And 6 squared is 36. So I can add 3 to both sides. 2x is equal to 39 divided by 2. X is not pretty. So 19 and a half. X is not pretty. 39 over 2, 19 and a half, doesn't matter which way you write it. I kind of hope it's not right because it's not pretty. I'd rather it be pretty, I think. So we have to plug it back in. Not pretty at all. 19.5 times 2 is 39. Minus 3 is 36. Square root of 36 is 6. Minus 2 really is 4. So it's correct. Ugliness and all. Now, I'd love to tell you that was it, but they do get a little bit harder. Not a lot, but a little bit harder. Same rule applies. Always got to make sure that you isolate the radical and then square both sides. Every once in a while, you have to isolate the radical twice. But I don't think you'll have any of those. I'm trying to work it out so that you don't. Let's look at example 6 and example 7. I think that's a plus. I think it's a plus. Try it. It's a plus. Just checking. Get a different color. Okay. So for this one, the radical's by itself. So I can go ahead and square both sides. When I do it on this side, my radical cancels out with my square. And I'm left with 3n squared plus 12 is equal to. Doing it on this side, 3 squared is 9, and n squared is n squared. Got to square both of them. So now, I have to solve. have squares. When you solve with squares, yeah, that means you're going to have to factor. So everything's got to be on one side equal to 0. And I'm going to want it on this side because I need my square term to be positive. So minus 3n squared minus 12 minus 3n squared minus 12. 0 equals 6n squared minus 12. Factor a 6 out. N squared minus 2. So either 6 is equal to 0 or n squared minus 2 is equal to 0, right? Okay. 6 can't be equal to 0, so we know it's not that. So 0 must equal n squared minus 2. Have to add 2 to both sides. And get 2 is equal to n squared. And now I can take the square root of both sides. So n is equal to the square root of 2. Technically plus or minus the square root of 2. Woof. Hold that thought just 1 second. That's what that says. That's what that says. N squared minus 3 minus 12. Yeah, positive 6n squared. Sorry, this is how I check stuff. Minus 12, take out a 6, leaves me with n squared minus 2. It's not the difference of 2 squares. So, technically, whenever you take the square root, it's a plus or minus. Did I mention I ain't liking this one? Because we've got to check that stuff. So, square root of 3 times plus or minus square root of 2. We'll do the plus one first. I'm not believing that it's true anyway. Plus 12 is equal to 3 square root of 2. So that's what that said in the red. So that's squared. Square root of 3 square root of 2 squared makes that go away, so that's just going to be 3 times 2 plus 12. So square root of 6 plus 12 is square root of 18. 18 really is 3 square roots of 2. Well, how about that? But we got to go back and check the negative, because there are 2 of them. So when I go back and I check the negative, that makes that a negative, and that makes that a negative. So it will be a negative 3. So now, a negative squared is still a positive, still gives me the 6, still gives me the 18, still gives me this. Does not give me a negative 3 square roots of 2. So it can't be the negative one, it's only the positive one that's my answer. Now you only need to worry about that when it's a letter underneath the square root. When it's a letter underneath the square root that you're taking, that's when you have the plus or minus thing you have to worry about. I didn't like that one. It wasn't very pretty, but okay. Moving on. This one looks difficult because it has 2 square roots in it. But if you'll notice, they're both by themselves. So when I go to square this side and square this side, this radical cancels out that, and I'm left with 3y minus 5. And this radical cancels out with that, and I'm left with 5y minus 3. So I can move my 5y, add my 5, which gives me negative 2y equals positive 2. Divide both sides by negative 2, y equals negative 1. Now we just got to plug it back in. So 3 times negative 1 is negative 3. Ooh, let me write this one down. So that's going to give me the square root of negative 3 minus 5, which is the square root of negative 8, which you can't have. 5 and negative 1 is negative 5 minus 3, which is the square root of negative 8, which you can't have, but I'm going to say that it's okay. Because it really does mean something in math. We just haven't gotten to what it means yet. So we're calling this one checked. If they do something different in your book, then we'll have to talk about that later. 2 more to look at. Example 8, m minus 4 equals the square root of 2m minus 5. And the square root of x minus 1 equals 2 minus the square root of x. Because I need to get one in there. Normally, I'd tell you to go ahead and try it on your own. But I have a feeling you'd make a mistake, so I'm going to help you with it. So we have to square both sides, right? So I square that side, and that cancels out. And I come over here, and I have to square this side. But you have to remember that when we have a binomial square, that means we multiply that whole binomial by itself. So that means that it's m minus 4 times m minus 4, because you got to write it twice, equals the 2m minus 5. So m squared minus 4m minus 4m plus 16 equals 2m minus 5. M squared minus 8m plus 16 equals 2m minus 5. Subtract my 2m and add my 5. So I could get it equal to 0. Plus 21. That's 3 and 7. They're both negative, equal to 0. So m minus 3 is equal to 0, or m minus 7 is equal to 0. Plus 3, m equals 3. Or plus 7, m equals 7. We don't know which one's right, if either of them are right, until we plug them back in. So I take my 3 and I put it in up here. 3 minus 4 is negative 1. Over here, 3 times 2 is 6, minus 5 is 1, and the square root of 1 is 1. Does negative 1 equal 1? Nope. So it's not 3. Let's try 7. 7 minus 4 is 3. And then 7 times 2 is 14, minus 5 is 9, and the square root of 9 is 3. So that means the 7 does work. Just because one of them didn't work does not mean that the other one does. It's possible that neither of them will work. You always have to check. One more. This one's challenging for you. So we already have the radical by itself, but we have another radical that isn't by itself. When that happens, go with the one that is by itself. It's okay. We're still going to have to square both sides, but at least this is the biggest one. So I'm going to square this side and square that side. So you've done this before. So over here, the square root really cancels out with the square, and we're left with x minus 1. Over here, since it's a binomial, that means we have to write it twice. 2 minus the square root of x times 2 minus the square root of x. Then we have to FOIL it out. 2 times 2 is 4, minus 2 square roots of x, minus 2 square roots of x, plus square root of x squared. Well, that's 4 minus 2 square roots of x, and 2 square roots of x makes it 4 square roots of x. And then square root of x squared is just x. Before we said we had to isolate the radical, we have to do that again. So I'm going to move my x over here. No, I'm not. Yeah, well, it's okay. I'll move my x over here by subtracting. And I'll subtract my 4 too. That'll get rid of that and that. X minus x leaves me with no x's, and I get negative 5 equals negative 4 square roots of x. Divide both sides by negative 4 to get rid of that. And you get a positive 5 over 4 is equal to the square root of x. And now we have to take we have to square both sides again. So that gives us 25 over 16 is equal to x. Technically a plus and minus. I'm just going to check the plus one. So, it's a lot of writing, but I can handle it. Square root of 25 over 16 minus 1 equals 2 minus square root of 25 over 16. This side I'm going to do first, because I know the square root of 25 over 16 is the square root of 25 over the square root of 16. So I'm going to get 2 minus 5 over 4. And 2 is really 8 over 4, common denominator and all, which leaves me with 3 over 4. Over here, common denominator and all, square root of 25 over 16 minus 16 over 16. 25 minus 16 is 9 over 16, which means it's the square root of 9 over the square root of 16, which is really 3 over 4. And that equals 3 over 4. So that means this is correct. Nasty, but right. Which leaves us only talking about classwork and homework. Yay for you. It's on page 522. Classwork is numbers 3, 9, 13, 19, 29, and 33. And then homeworks is numbers 1, 11, 15, 21, 25, 27, 31, 35, and 37. Challenging. And we'll see you tomorrow. Ish.